Relate molecular structure to boiling point. The boiling point of a covalent molecular compound depends on the overall strength of the intermolecular forces, IMFs, holding its molecules together. The weaker these intermolecular attractions are, the less energy is required to separate the molecules, resulting in a lower boiling point. Compare the overall structures and dipole moments. Both chloroacetic acid and iodoacetic acid share the same basic molecular skeleton, XCH2COH, where X represents the halogen substituent. Because they have the same shape, their permanent molecular dipoles are highly similar, meaning their dipole-dipole forces are of comparable strength. Compare the size and electron shell configuration of the halogen substituents. The chlorine atom, Cl, resides in period 3 of the periodic table, whereas the iodine atom, I, resides in period 5. Therefore, the chlorine atom has fewer occupied electron shells than the iodine atom. Determine electron cloud polarizability. Because it has fewer shells, the chloroacetic acid molecule possesses a smaller, less polarizable electron cloud compared to the larger iodoacetic acid molecule. Relate polarizability to the strength of London dispersion forces. Since London dispersion forces scale directly with electron cloud size and polarizability, the London dispersion forces among chloroacetic acid molecules are weaker than those among iodoacetic acid molecules. Identify the compound with the lower boiling point. Because chloroacetic acid exhibits weaker London dispersion forces, its molecules are held together less tightly in the liquid state. This results in a lower boiling point for chloroacetic acid, which corresponds to option A. The correct answer is option A, chloroacetic acid, because it has weaker London dispersion forces than iodoacetic acid.